Welcome back. So, 2 videos ago, we talked about how to solve systems of equations. So here's a system of equations, right? I could use the elimination method, um, though it's not totally obvious. Well, it is to me, right? So, what would I multiply the first equation by? Well, perhaps I could multiply it by the whole thing by 4, and I can multiply this whole second equation by -3, right? So this 4y will become -12, and this 3y will become +12, right? So I multiply the whole first equation by 4 and the whole second equation by -3, add them together, eliminate y, solve for x. Once I've solved for x, plug it into one of the equations, and then solve for y. Okay, that's perfectly fine. I'm going to give you another way to think of it, right? So that we can start using those matrices. Well, what is this? This is essentially a matrix equation. How? Well, I can think of it as 2, 3, 5, 4, x, y, 7, 8. Right? So if I think of 7 and 8 not as two separate things, but as one entity, 7, 8, then clearly when I look at this, right, when I multiply 2 by x and 3 by y, this is going to give me a vector, right? Because from our lecture 2 days ago, if I have a 2 by 2 matrix and a 2 by 1 matrix, the new matrix should be 2 by 1, right? Because the inner dimensions match, and so the new dimensions are on the outside. Well, indeed, this is a 2 by 1. So if I just look at the outside, this part right here, or rather the left side, if I multiply those, I should get the following matrix. I should get 2x, right, 2 times x, plus 3 times y, and 5 times x, plus 4 times y. Okay, so this whole thing up here, 2x plus 3y, that's exactly one number, okay? And the bottom part, 5x plus 4y, that's also one number. So basically what we have going on here is this is a 2 by 1 matrix. And I'm claiming that it's equal to 7, 8. Okay, now let's compare this to this up here. As you can see, it's the same thing, right? But instead of 2 equations, this is 1 equation. I've converted 2 equations into 1 equation. But instead of, I guess you could say, one-dimensional objects, this is a 2-dimensional object, right? It has 2 parts. It has the first coordinate, and it has the second coordinate, right? So the first row, the second row. Okay, so you might say, looking at this equation here is just as difficult as this equation. So why bother doing this? Good point. I'm just trying to show you that I can go from here to here by adding the brackets, right? Just like I can put a single number in brackets and call it a 1 by 1 matrix, so too I can do this. I put my brackets around it, right? Put my brackets, right? And there, you can see they're the same thing. Okay, but mathematics isn't just about putting brackets around stuff, obviously. But I can go from here to here, and this is what I like. I like this equation. Why do I like this equation? Well, in the previous video, I discussed matrix inversion. Okay, so I told you how you can invert an equation. Sorry, a matrix. Why is this helpful? Well, let's look at this. So this matrix right here, I could call it A. This matrix I can call V, as in Victor, and this one I can call B as in boy. Okay? So I have A, V equals B. Now, I know A and I know B, right? So what I really want to do is find V. And V has X and Y. I don't know X and Y. Well, earlier I said that if I have A times A inverse, I get the identity matrix. And the identity matrix does absolutely nothing to anything it touches, right? So why don't we use that and solve this system? So let's just do some simple algebra. I'm going to multiply both sides of this equation, this matrix equation, by A inverse. Okay, so when I multiply both sides of this equation, I can easily see that this is the identity, right? Because that's what it means to multiply a matrix by its inverse. You get the identity. So I have IV equals A inverse B. But what is IV? IV is just V, right? IV is just V because, again, that's how it works. If you don't believe me, this is 1001 xy, right? This is I and this is V. And if I just carry the calculation out, I get V back, right? 1 times x is x, plus 0 times y is 0. So x plus 0 is x. And then again, I get it for y. So that's just a very routine calculation. Okay. So the whole point of all of this is to say that xy equals A inverse B. Great. So all I have to do is invert this 2 by 2 matrix and then multiply it by this. Well, to do that, I have to find the determinant of this matrix. So what is the determinant of, I'll call this A. So what's the determinant of A? Well, it's 2 times 4 minus 3 times 5, which is 15. So this is 8 minus 15, which is what? Negative 7? Okay, so the determinant of A is negative 7. Great. This is very good. So A inverse is 1 over negative 7, 1 over the determinant, times my original matrix, but I'm going to modify it. So I take the diagonal elements and I'm going to swap them. So 4, 2. Okay, 4, 2. And then the off-diagonal elements, I'm going to negate them. Okay, now I could pass this through. There's nothing wrong with that. I could multiply this through. But there's really no need to do that because I can do that at the very end. So instead, what I'm going to do is I'm just going to hold off on that. So xy equals 1 over negative 1 over 7. I move the negative up, and it's 4, negative 5, negative 3, 2 times 7, 8. Okay? 7, 8. Now we're going to do some algebra. Okay, so this is a 2 by 2 matrix, and this is a 2 by 1 matrix, and so the resulting matrix has to be 2 by 1, right? 2 by 2, 2 by 1, the inner dimensions match, so the new dimensions are the outer dimensions. Okay, so 4 times 7 is 28, plus negative 3 times 8 is negative 24. Outer dimensions are negative 35 plus 16. Okay, good. So you have negative 1 over 7 times 28 minus 24. This is 4. And 35, negative 35 plus 36. Well, this is 35. It's the 35 minus 16 is what? I cannot add. Okay, so that's 19. Okay, so it's negative 19. Okay, so what this tells us, after we're totally done, okay, I don't have that equation memorized that I started off with, but you've probably written it down while you're watching this video, and so you can just reference back to it. What it tells us is that the vector xy is equal to negative 1 over 7 for negative 19. Well, that's not a very satisfying answer, but we can convert it into a satisfying answer. So it's x equals negative 4 divided by 7, and y equals 19 divided by 7, right? The negatives cancel, and you get 19 divided by 7. So this concludes the basics of matrix inversion. In the next video, we'll discuss the geometry.